There are many kinds of energy in the universe. The energy that is given off by the sun is called radiant energy, scientifically known as the electromagnetic radiation. The energy streams coming from the surface of the sun are of different wavelengths. The shortest and the longest wavelengths are invisible into our eyes, while the medium wavelength are the visible radiations we call as the sunlight. And most of the sun's energy is released in this visible wavelength. All substances have kinetic energy that is expressed by the vibrations of their atoms and molecules. These vibrations results into radiation. The electromagnetic spectrum, or the EM spectrum, is the name given to all of the different types of radiation. The electromagnetic radiation is a form of energy that spreads out as it travels. Visible light radiation that comes from a lamp in someone's house or radio wave radiation that comes from a radio station are two types of electromagnetic radiation. Other examples of EM radiation are microwaves, infrared and ultraviolet radiation, X-rays, and gamma rays. Hotter and more energetic objects or events create higher energy radiation than cool objects. Only extremely hot objects or particles moving at very high speeds can create high energy radiation like X-rays and gamma rays. On the other hand, some waves need a medium in order for them to move, and we call these as the mechanical waves. But on this lesson, we will just focus on electromagnetic waves.
The term electromagnetic wave tells us that electric and magnetic field are present in light. An electric current produces magnetic field around a wire, and that changing magnetic field creates an electric field.
In 1856, James Clerk Maxwell was doing a theoretical study of electromagnetic waves. He realized that a changing electric field gives rise to changing magnetic field, which in turn creates a changing electric field, and so on. He developed equations showing the relationship of electricity and magnetism. Based on these equations, he found that the net result of these interchanging fields was to create the rain of invisible waves of electric and magnetic fields that could propagate through space. Maxwell's theory of light was fully accepted after EM waves were first created and detected experimentally by Heinrich Hertz in 1887. Hertz gave experimental evidence that light and electromagnetic waves have the same nature and that they travel at the same speed and exhibit the same properties, such as refraction, reflection, diffraction, and interference. Each wave is different from one another in its wavelength, but all the waves travel in the vacuum with the speed of light at 3.0 times 10 raised to positive 8 meters per second. The wavelengths vary from 3 times 10 raised to positive 7 meters at low frequencies to 3 times 10 raised to positive 17 meters at high frequencies. It is found that the wavelengths of visible light ranges from 3.5 times 10 raised to negative 7 meters to 7.5 times 10 raised to negative 17 meters. The visible spectrum includes all radiation visible to human eye and is commonly called light. All radiation above and below the visible waves have wavelengths that are too short or too long for the eye to detect.
Now that we already know what EM wave is, let's discuss different types of EM spectrum and their uses in our daily lives. First are the radio waves. Radio waves have the longest wavelengths and lowest frequencies of all the electromagnetic waves. A radio picks up radio waves through an antenna and convert it into sound waves. Each radio station in an area broadcasts at a different frequency.
Next, we have microwaves. Microwaves have shorter wavelengths and higher frequency compared to radio waves. When used in microwave ovens, waves transfer energy to the water in the food, causing them to vibrate, which in turn transfer energy in the form of heat to the food.
Third is infrared. Infrared rays are below red, in shorter wavelength, in higher frequency than microwaves. You can feel the longest ones as warmth on your skin. Warm objects give off more heat energy than cool objects.
Next, we have visible light. It is shorter wavelength and higher frequency than infrared rays. It is the electromagnetic waves that we can see. Longest wavelength is red light, while the shortest wavelength is violet or purple light. When light enters a new medium, it bends or refracts. Each wavelength bends a different amount, allowing white light to separate into its various colors such as red, orange, yellow, green, blue, indigo, and violet.
Next, we have the ultraviolet rays. They are shorter wavelength in higher frequency than visible light. It carries more energy than visible light. It is commonly used to kill bacteria, particularly in sterilization of equipment. This light causes your skin to produce vitamin D that is good for teeth and bones.
Next, we have X-rays. These are shorter wavelength and higher frequency than UV rays. This carries a great amount of energy that can penetrate most matter. It is used by engineers to check for tiny cracks in structures. The rays pass through the cracks and the cracks appear dark on film. In medicine, bones and teeth absorb X-rays.
Last, we have gamma rays. These are shorter wavelength and higher frequency than X-rays, carry the greatest amount of energy, and penetrate the most. Used in radiation treatment to kill cancer cells, but can be very harmful if not used correctly.
Now let's talk about the hazards brought to us by electromagnetic radiation. Changes in atoms or the nuclei of atoms can result in the emission of electromagnetic radiation over a wide range of frequencies. Changes in the nuclei of atoms cause the emission of high-frequency gamma rays. The reverse of this also happens. If an atom absorbs EM radiation, it can result in a change in the atom or nucleus. This means that electromagnetic waves can have hazardous effects on body cells. EM waves with high frequencies have high energy so are able to cause the most damage. If a wave has enough energy, it can remove the outer electrons from atoms. It is called ionization. So, how do ionizing waves affect humans? Well, ionizing waves have enough energy to ionize the atoms in materials. These waves can have a severe effect on living tissue by killing cells or damaging DNA. Sunburn occurs when the skin is exposed to high-intensity UV radiation, which damages skin cells. Repeated exposure leads to premature aging of the skin and increases the risk of skin cancer. Intense UV radiation can inflame the eyes and long-term exposure may cause cataracts. X-rays pass through soft body tissue, such as skin and muscle, without being absorbed. Denser tissue, such as bone, absorbs some X-rays and can be ionized. Precautions must be used when X-ray images are taken. To minimize their exposure when an X-ray image is being taken, radiographers must wear a lead apron, stand behind a screen that absorbs X-rays, or even leave the room. Ionizing waves such as gamma rays can damage the DNA in cells and even kill cells. The risk that exposure to radiation presents can be measured using the radiation dose. A very high dose of gamma rays in a short time can be fatal. A low dose over a long period of time will increase the risk of a person developing cancer. Microwaves are radio waves with short wavelengths. They are very slightly absorbed by the body and can cause a minor heating effect. They are not strongly absorbed and are thought to have no effect on the health of living tissue. However, the microwaves produced by mobile phones have not yet been proved to cause health problems. Your eyes detect visible light, which does not normally pose any health risk. However, very bright light can damage your eyes and may even make you blind. This is why you should not look at the sun through a telescope or binoculars.
Thank you very much for watching. We hope that you learned. See you on our next topic. Bye!